Okay, students. Now you know the three equations of motion, which are v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, in which v is the final velocity, u is the initial velocity, a acceleration, s displacement. Okay, then let's understand how we can use these equations of motion in freely falling substance situation and motion under gravity. Therefore, in the case of free fall, what all ideas do we know? If a substance is freely falling, one idea that you can get is it is initial velocity is always zero. If a substance is in a state of free fall, the initial velocity is zero. As it is falling down, its magnitude of velocity is increasing. Therefore, the acceleration in the case of free fall is taken as g. That is acceleration due to gravity. Therefore, in the case of free fall, you could simplify the equations of motion as you could take u is equal to 0 and a equal to g. Therefore, first equation of motion can be rewritten as v is equal to 0 plus gt. Then v is equal to gt. This is how we can simplify the first equation of motion in free fall situation. Then in freely falling situation, the second equation of motion can be replaced as s is equal to ut plus half at square can be replaced as s is equal to 0 plus half gt square. Since u is 0, this term will become 0. Then you could even write h is equal to half gt square. Then the third equation of motion, it can be written as v square minus u square equal to as. Therefore, we could write v square minus 0 is equal to 2gh. That is v square is equal to 2gh. This is how we could simplify the three equations of motion in the free fall situation. Okay. Therefore, let's understand some basic problems by using these equations. For saying about a basic problem, let me say a substance is dropped from a tall building which is of 2 meters. A substance is dropped from a tall building which is of, it's not 2 meters, it's not a tall building. Therefore, let's take let me say 200 meters. Okay, 200 meters. Then if we are dropping a substance from the top of the tall building, what is the final velocity attained by the substance and what is the time in which the substance is reaching the ground? This is the two things asked in this situation. Then in this situation, since it is freely falling substance, you could use these relations. Then let's initially find out the velocity. In order to find out velocity, the data that are given is h is given as 200 meters. Then they have given u, it is free fall. Since it is free fall, u is 0 and g can be taken as 9.8. For my simplification, I am taking it as approximately 10 meters per second square. Then we could use this equation to get the final velocity. That is, we could write v square is equal to 2gh. Therefore, v is equal to root of 2 into 10 into h, it is 200. Therefore, we could write it is root of 400 into 10. That is, I could write it as 4000, but I am writing root of 400 into 10. Then 400's root is 20. 20 root 10, and if I am using the approximation, root of 10 is approximately equal to root of 9. Therefore, I could write 20 into 9 point something. Okay. Therefore, this should be the final velocity. Final velocity. Then, if you are asked to find out the time required, if you could find out the time required by using the equation v is equal to gt and t is equal to g by v. Therefore, t is equal to g is taken approximately as 10 divided by v. V is, I could write it as root of 4000, that is 10 divided by what? 20 root 10, that is root 10 divided by 20, that much second. Okay, this is your answer, and velocity will be this much meter per second. Okay, therefore this is how we are finding out the final velocity and final time. I'm not simplifying it. You could simplify it and get a clear cut answer. Okay, therefore this is regarding freely falling situation. Then let's understand the next situation, that is, if a substance is thrown upwards, object thrown upwards. Therefore, in the case of object thrown upwards, is the initial velocity 0? In the case of an object thrown upwards, is initial velocity 0? No. Initial velocity is not 0. Then which is 0? The velocity at the highest point is 0. That is, let's discuss the next situation, that is object thrown upwards. Object thrown upwards situation. In the object thrown upwards situation, we are having a substance which is initially projected with a velocity u, so that it is reaching a maximum height of this much. This is the maximum height reached by this substance. That is, as the substance is moving up, its velocity will decrease, and at the highest point, the final velocity will be 0. This is the key thing that you have to understand in object thrown upwards. In the object thrown upwards situation, the final velocity is 0. Then the next thing that you could use is, since the magnitude of velocity is decreasing, you could say acceleration is minus g. I could take acceleration as minus g. Then let's rewrite the equations of motion for object thrown upwards situation. For object thrown upwards situation, we could write the first equation as, the first equation can be rewritten as 0 is equal to u plus gt, that is u minus gt. Let me write minus gt, since a is minus g, u minus gt. Then you could get u is equal to gt. This is the simplified form of our first equation of motion if the object is thrown upwards. Okay. Then the second equation of motion, actually it is s is equal to ut plus half at square. We could write h is equal to ut minus half gt square. H is equal to ut minus half gt square. This is how we could write the second equation. There is no term which could be equated to 0. Therefore, we will have to retain it as such. Then the third equation, it is v square minus u square equal to 2as. It can be rewritten as 0 minus u square is equal to minus 2gh. That means u square is equal to 2gh. Okay. Therefore, the three equations could be modified in the case of object thrown upwards as these three. These are the three equations that is used in the object thrown upwards, or you could directly remember v is equal to 0 and a is equal to minus g. Let us understand the situation with the help of a problem. That is, let us have a ball over here, and this ball is of 10 kilogram. A 10 kilogram ball is thrown upwards with an initial velocity of, let us say, what, 200 meter per second. What is the maximum height reached by this ball? That is the first question. The next part of this question is, what's the time taken for the object to reach the maximum height? Time taken for this object to reach the maximum height. In order to find out that, we will have to use the equations like this, and let's say what all things are given in this. It is given u is 200 meter per second. A can be taken as minus g. Okay, then it is given the mass is 10 kilogram. Then we could use u and a in this equation. That is, let us write u square is equal to 2gh. Then how can we find out h? Can be obtained by u square by 2g. Then if you are substituting u square, it is 200 square. 200 square divided by 2 into g can be approximated as 10. Okay. Then we could write the answer as 200 square is what? 4 with 4 zeros. Then divided by 20. 1 zero will get cancelled. Then it will be what? It should be 2000 meter. H is 2000 meter. Then in order to find out the time in which it is reaching the maximum height, you could use this relation, that is u is equal to gt. Then we could write t is equal to g by u. T is equal to g by u. In this case, it is 10 by what is u? 200. Therefore, you could substitute the values and 1 by 20 seconds. Okay. Therefore, this is the answer. It will reach the maximum height in 1 by 20th of the second. Then the maximum height reached in this situation, it will be what? 2000 meter. Okay. Therefore, this is regarding freely falling situation also. Hope you have understood these two sessions. This is how we are using equations of motion in free fall situation and object thrown upwards. You have to remember, in freely falling situation, initial velocity is 0 and acceleration due to gravity is g. In an object thrown upward situation, the initial velocity is not 0, but final velocity is 0. That is, the velocity at the maximum height situation is 0 and acceleration is minus g. Okay.